Good morning, students. Today is Wednesday, November 3rd. It is a B day, and we're going to continue with what we started, which is we will understand and use exponents and exponential expressions. So you started that already, and you've been working pretty hard on that, which I appreciate. So let's get started. Remember, take a few moments to get yourself centered and focused. You need to make sure you have your lesson paper. When you're finished, make sure your binder is updated so you'll put your lesson page at the end as the last page in the pages that are already in there. And I have an exit thought for you to think about today. So when we are finished, besides being centered and ready to work, you'll have your computer, your completed lesson page all done, hopefully. Your work will be hole punched and in your binder, and you will have answered the exit question. So make sure you get a lesson page, you have a pencil, go to Schoology on your computer and get started. So here we go. And I like to remind you in these beautiful fall days that you can do this. So today's learning target is to understand and use exponents and exponential expressions. So we started this already, so this is a little bit of a review. We are asked to rewrite each expression using exponents and then evaluate if possible. And in some cases, we will not be able to evaluate because the exponents will be attached to variables. So the first thing we do with number 1, as I look at 5, I've repeated multiplication. So remember, exponents are repeated multiplication. I have 1, 2, 3, 4, 5, 6, 7, 8 fives. That does not mean 5 times 8. 5 times 8, let's write that down. 5 times 8 would be 5 plus 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 5. That's 5 times 8. That is not what we're talking about here. Here we have multiplication. So we express that as an exponential expression with a base of 5 and an exponent of 8. Now, we can evaluate by using a calculator and putting in 5 times 5 times 5 times 5 8 times, or we can learn the function for an exponent, which on most calculators is this little caret sign. So you would put in the base of 5, then the caret sign, and the 8, and that will give you an expression, and it will evaluate the expression 5 to the 8th power, which is, remember, exponential expressions get large very quickly. So this will be 390,625. So again, let's look at number 2. It's not 9 times 9 times, it's not 9 plus 9 plus 9 plus 9. It's not 9 times 4. It is 9 times 9 times 9 times 9. That's a base of 9 with an exponent of 4. And when we evaluate 9 times 9 times 9 times 9, we have 6,561. And I hope that you are doing these on your own. Pause the video, try them on your own, and then check your work. Okay, number 3, we have negative 16 times negative 16, and those parentheses are so important when we have a negative sign. So we write that parentheses, negative 16, raised to an exponent of 2. And if you'll remember from our last lesson, when we have 2 negative terms multiplied by each other, we will have a positive answer. So whenever the number of terms, the number of negative terms is even, like 2, 4, 6, or 8, etc., then when we evaluate, the answer is positive. Okay, but when the number of negative terms is odd, like 3 or 5 or 7, then the answer is negative. Okay, well, here we have an even number of terms, so we will have a positive solution, and negative 16 times negative 16 is 256. So let's go on to the next page, and we will keep trying our best because that's what we do. So we're going to again rewrite each expression using exponents, and then if possible, we will evaluate. So in this case, number 4, we have 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. That is not 1/2 times 7. It's 1/2 times 1/2 times 1/2 and so forth. So if we multiply the numerators, well, let's write the expression first. It would be 1/2, the entire thing in parentheses, raised to the 6th power. So now if we multiply all those numerators, 1 times 1 times 1 times 1 times 1 times 1 times 1, we will have a 1 in the numerator. When we evaluate the denominators, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. And that's our final answer. Now, with number 5, we have -1 in parentheses, and there are 3 of those being multiplied together, so that has an exponent of 3. But remember our even and odd rule. If we have an odd number of factors, then our answer will be negative. So -1 times -1 is +1, but then when we multiply again times -1, the answer will be -1. So number 6, I hope you try it on your own. So I can rewrite this. I have, let's think about this. I have -2, -2, -2. So I've got 3 of those. Using the parentheses with a negative number, I have -2 to the 3rd power times, and let's count the 3's. 1, 2, 3, 4, 5 times 3 to the 5th. Now, -2 to the 3rd power equals -8. And 3 to the 5th power equals 243. And -8 times 243 is negative. The negative times a positive is negative 1,944. So that's our final answer, negative 1,944. So let's move on to problem 7, 8, 7 and 8. Try them on your own. So for number 7, we have 2 8s, so that will be 8, a base of 8 with an exponent of 2, times the fraction 3/4, which is raised to the 3rd power. So let's think about what we have here. 8 squared, or 8 to the 2nd power, is 64. If we know our squares, and we'll be memorizing those, we will understand that. But -3/4 raised to the 3rd power is -3/4 times -3/4 times -3/4. So let's look at that. I'm sorry, not negative, +3/4. 3/4 times 3/4 times 3/4. So 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. So that ends up being 64 27 64ths times 64. So we know from that that our answer will be less than 64. We have to have an answer that's a lot less than 64. And indeed, 27 64ths would equal 27. Okay, let's move on to number 8. Now I'm going to clear our page a little bit. So for number 8, I just have a variable. I have n, and I have 1, 2, 3, 4, 5, 6, 7 of those. That would be n to the 7th power. Now we cannot evaluate n to the 7th power. So our work is done with that respect. Were you able to figure that out on your own? I hope so. So number 9, so we've got, remember the commutative property means that we can move these terms around, and that's okay. So we have -4, and we have 1, 2, 3, 4 of those. -4 is our base raised to the 4th power times, and our xy term, we have 3 of those, xy to the 3rd, and I'm putting xy in parentheses so that I can include both the x and the y as having the exponent of 3. The exponent of 3 applies to both the x and the y because I have the entire group of xy 3 times. So we cannot evaluate xy to the 3rd power, but we can evaluate -4 to the 4th power, which equals 256. Remember, an even number of bases, negative bases, will give us a positive solution. So we do have that 256, and then we have x, y to the 3rd power. So let's go on to number 10, the last one in this group. I have the quantity of x minus 7y. Okay, it's a quantity, it's in parentheses. And I have 4 groups of x minus 7y. So that means that I just put an exponent of 4. And I cannot evaluate that, okay? Because I have variables. Because the 7 is multiplied by y, so I can't even do 7 to the 4th power. We wouldn't do that. So this cannot be evaluated unless we have a known value for those variables. Okay, so for the rest of this, we are asked to rewrite each expression using positive exponents. So remember, anything raised to the 0 power equals 1, and anything with a negative exponent will move to the denominator of a fraction. So we have 7 to the -2 power, and we can rewrite that as 1 over 7 to the 2nd power, which equals 1 over 7 times 7, which equals 1 over 49. So I hope you try these on your own before you check them. Number 12, I have 10 to the -3rd power, which will be 1 over 10 to the 3rd power, which is 1 over 10 times 10 times 10, which equals 1 over 1,000. Number 13, another negative exponent. This would be 1 over 4 to the 5th, which equals 1 over 4 times 4 times 4 times 4 times 4, which equals, you'll need a calculator to help you, probably 1 over 1,024. And then number 14, the numbers are going to get a little large here. They'll be small in that they're in the denominator, but you will probably need a calculator. We're going to have 1 over 3 to the 7th times 1 over 2 to the 4th. Now, 3 to the 7th equals 2,187. Remember, we're multiplying here. 2 to the 4th equals 16. 1 times 1 is 1. And 16 times 2,187 is 34,992. I hope you were able to do that on your own. And pat yourself on the back if you did that and you got it right. You're learning. The more you practice, the more you understand. Number 16, we have 6 to the 2nd power times 12 to the negative 2 power. So we can rewrite that as 6 to the 2nd power over 1. We can put anything over 1 times 1 over 12 to the 2nd power. We're removing that negative exponent. So 6 to the 2nd power is 6 times 6. That is 36. And 12 times 12 is 144. And 36 is actually a factor of 144. So let's multiply across. We have 36 over 144. And if we divide 36 by 36 and we divide 144 by 36, we will get a final answer of 1/4. Now, if you didn't see that 36 was a factor of 144, you could just start dividing by smaller numbers, but you would always finally get to 1/4 as your answer. So number 16, we have 2 to the 0 power times 15 to the 3rd power times 9 to the negative 4th power. So 2 to the 0 power equals 1. Anything raised to the 0 power equals 1. So we have 1 times 15 to the 3rd times, we'll get rid of this negative exponent, 1 over 9 to the 4th. And let me rewrite that so it's a little clearer to see. Okay, so 15 to the 3rd power is 3,375. And 1 times 3,375 is 3,375. I can put a 1 under there just to remind me that I'm multiplying two fractions. And 9 to the 4th, 9 times 9 times 9 times 9 is 9,651. I'm sorry, 6,561. 6561. So what we can do, we'll start here. And you can just start dividing this. It's hard to recognize what the factors would be. But you can try to take some guesses. For example, with these two numbers, I would try to start with 3 and see if they're divisible by 3. And I would just keep going until I had the smallest number that I could. It just so happens they are both divisible by 27. And I figured that out by just kind of playing around with my calculator. 3,375 divided by 27 is 125. 6,561 divided by 27 is 243. And that's our final answer. And number 17, we have y to the negative 8. Remember, we cannot evaluate a variable unless we know what to substitute for the variable. But what we can do is we can get rid of the negative 8 by putting y in the denominator with an exponent of 8. And number 18 is very similar, except we have a more complicated expression here. But this time, a will be in the denominator. In fact, let me just write that a little more neatly for you. You can put these both a and b, under the same denominator with a numerator of 1. So it would be a to the third, b to the fifth power. And now your work is done. And we have just 2 more problems. So number 19, r to the negative 8, 6 to the negative 6 power, and t to the 0. So we will write 1 over r to the 8th times 1 over s to the 6th times anything raised to the 0 power, even a variable, is 1. So let's cleanly write that fully evaluated expression. We will have 1 over r to the 8th, s to the 6th, and that's our final answer. There's nothing more we can do with that. Now, a little more complicated, 4 to the negative 2 power. We can evaluate that. C to the third, d to the negative 1 power. So let's first look at 4 to the negative 2. That would be 1 over 4 with an exponent of 2 times c to the third power, and multiply that times 1 over d to the first power, and that will become an invisible 1. We can erase that. So let's look at what we have. We know we can put a denominator of 1 under anything if that helps us understand our multiplication. So in the numerator, we have 1 times c to the third power times 1. In our denominator, we have 4 to the second power. That's 4 times 4. So that's 16 times 1 times d. Well, we can simplify this. In the numerator, we'll simply have c to the third power. And in our denominator, we'll have 16 times 1. That's 16 times d, which we would write as 16d. And that's our final answer. So good job today. I want you to think about this final question. What is the value of a non-zero number or variable raised to the 0 power? And that equals 1 every time, unless the number is 0. And how should you simplify negative exponents? Put negative exponent terms in a denominator. Make the exponent positive. So there you have it. Before you go, please remember to clean up, leave the room nice and neat for the next class. Don't forget all your things. Return anything that you borrowed, including pencils. Have a beautiful fall day. You're working hard, and I'm so proud of you. And remember, with math, it takes practice, and with practice, you'll be great.